Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I solved around 4 months ago. So looks like I tried it a bunch of times and we'll go over it again. So this one's called shortest word distance number 2. So it asks you to design a data structure that is going to be initialized with a string array, and it should answer queries of the shortest distance between two different strings from the array. So you're given a class here, and basically you have the input, and then you want to return an integer, the shortest distance between word 1 and word 2 in words dict. So the first thought that comes to mind is just to create a dictionary of type list, because we want to go through each word and then keep track of every index where that word appears. So if you have hi, you'll have hi as the key and then 0 as one of the indices. So for W in words dict, self.dw.append I. So let's do an enumerate. And then the shortest distance between word 1 and word 2. So ideally they're going to be keys in the dictionary. So if word 1 in self.d and word 2 in self.d, then we just find the, for each one in self.d word 1, I guess you find the closest one in self.d word 2. So actually let's make this a sorted list so we can use binary search. And let's just go through for index in self.d word 1. Let's do a bisect right to find the exact position if this appears in self.d word 2, right? That's where it starts. Inside of self.d word 2, the closest to index. So if b is less than self.d word 2, let's print index and self.d word 2 b. Okay, it's a bit slow, but 1 and 3. Let's do this brute force first. So let's actually print self.d word 1, self.d word 2. Okay, so that's 0. Obviously, this is going to be 3 and 1. Okay, so yep, as I said, so for index and self.d word 1, we're going to find the closest here. So again, bisect right inside of self.d word 2 using index. If b is less than length of self.d word 2, then we can just do that. Otherwise, it's going to be 1 here because the index 1 is going to be too big. So otherwise, L if b is less than 0, then b equals 0. L if b is bigger than 0, b equals length of self.d word 2 minus 1. Okay, so in this case, it's fine because we found it inside. So if this is 3, we return index 0 because that's where if 3 occurs in here. So you would just return 0 because that's the shortest distance. Otherwise, you would just return absolute difference of index minus self.d word 2 b. Hopefully. Nope. So 0. It's too big. L if b is bigger than or equal to length of self.d word 2, again set it. Oh, sorry. Yep, length of self.d word 2, not 0, right? Why is this not working, right? So now you would just get index and self.d word 2b. That's 0. Why is it 0? Is it -1? Let's print index self.d word 2 and then b. Okay, so 3, yep, that's 1 as expected. Oh, okay. Just because 1 is closest to 3 doesn't mean that 4 and 3, we still have to value all the options, right? And find the best one, which is the minimum. Answer equals minimum of answer and absolute value of this difference. Then at the end, we can return answer. Equals parentheses. Nope. Why is this not right? One, 3, 4, 3. Wait a second, this is not right. So if it's less than 0, maybe we shouldn't do it like that. Oh, sorry. Your answer is minimum of answer. So if we're valid, we found it in there, we don't even care about that, right? So if, there we go. So because this is valid, we found the result in there. Okay, so now 2, 1, 4, yeah, it should be 1. So let's do this. Okay, so let's see. Yep. It's 1. Oh. And also b plus 1, b minus 1, index 1. Maybe also index like this, because saying 2 is closest to 4, that's where it's supposed to be placed, but 1 is also closer to it. And there you go, passes all test cases. So again, just some binary search stuff and sorting arrays. So it shouldn't be that difficult. Again, I'm pretty happy that I solved this on my own. So pretty few test cases. So that's it for this video. Thank you for watching and stay tuned for more.